Hi, my name is Holger Schwarz. I'm working as a product marketing engineer at NADA Safety Test Solutions in Germany. Today, I would like to show you a dynamic range comparison of different spectrum analyzer and receiver. And here are our four candidates. We have taken the best of each class. The class of handheld spectrum and network analyzer, the class of portable radio monitoring receiver, and the class of real-time spectrum analyzer. Number 1. The Anritsu Spectrum Master MS2720T. The Spectrum Master is a representative of the market segment of handheld spectrum analyzers. The RF parameter like displayed average noise level DANL, the IP2 and the IP3 values are best in class compared to Rohde & Schwarz FSH or Keysight Fieldfox, so the ideal competition in the class of portable spectrum analyzers. Number 2. The PR100 or DDF007 from Rohde & Schwarz. The PR100 represents the market segment of portable radio monitoring receiver. In terms of sensitivity, it's one of the references in the market. Number 3. The RF Hawk from Tektronix, also known as H500 or H600. Moreover, the Hawk represents the class of portable real-time spectrum analyzer. With its DPX technology and the 20 MHz real-time bandwidth, it's a milestone in handheld real-time spectrum analysis. So far, there is no real successor from Tektronix. The RSA series of compact USB bricks might work on a table of a lab, but it's no solution for portable outdoor use. Last but not least, number 4, the challenger, the NADA SignalShark. It is desktop performance in a handheld. 40 MHz real-time bandwidth with a probability of intercept of 3.1 microsecond and 16 bits resolution is a challenge to the competition. In terms of dynamic range, the SignalShark has a high dynamic range and is close to ITU specs. So let us see if the SignalShark can keep its promise. So, why is a high dynamic range so important? Imagine you are a network provider and your system is telling you in one segment of your network you have a huge number of dropped calls. The trouble ticket from your mobile phone station indicates noise level too high on one antenna segment. The reason could be that somebody is interfering in the receiving band of the cell site. Possible troubleshooting scenario? You drive to the antenna site and measure with a receiver or spectrum analyzer and a directional antenna in the same direction the suspected antenna is pointing. Requirement for the analyzer? To be as sensitive as possible to see the interfering low-power uplink signal and at the same time capable of larger signal immunity for the emitted downlink signals from the base station. A high dynamic is demanded. Dynamic is the combination of different parameters. In our case, the sensitivity, the harmonics or IP2, and the intermodulation or IP3. These three parameters describe the dynamic of our test candidates. If you would like to know more about this topic, NADA provides 2 technical notes explaining, for example, the difference between harmonic distortion and IP2. We also did several comparisons of analyzers based on the datasheets and in relation to the requirements of the ITU Handbook of Spectrum Monitoring. For all tests for the evaluation of the dynamic range, it is absolutely essential that sensitivity, harmonics, and intermodulation are measured without changing the setting of the input attenuator or to switch on the preamplifier. Moreover, for all analyzers, the setting should be equivalent. Only by this you can make a fair comparison of the dynamic range. So the basic conditions are same setting for all analyzers, preamp off, input attenuator to 0 dB. Same setting regarding frequency range, resolution bandwidth and the detector. Slight differences are possible as long as they are not relevant. And the screen size is normalized. For best comparison, we have chosen an amplitude range which is equivalent for all analyzers. Let us start with the first test with a test of the sensitivity of the analyzer. We connect the instrument with a test generator. Center frequency of the analyzer and frequency of the test generator are slightly different. By this, the signal is easier to see on the screen of the instruments. Setting of all instruments is equal. We apply the same signal to each analyzer. Then we reduce the signal level step by step until the signal level disappears in the intrinsic noise tunnel of the analyzer. Remember the rule of thumb: 6 dB better signal-to-noise level means you can measure double the distance or 4 times larger area. Now you can see the 4 displays of our analyzer. On the left-hand side, the NADA signal shark. You can see here the level of minus 80 dBm, at the noise floor at around minus 133 dBm. For smoothing the noise, we applied an averaging time of 33 milliseconds. To its right, the Anritsu SpectroMaster. We applied a video bandwidth of 30 Hz. What you can see immediately, that the noise floor of the Anritsu is approximately 10 dB higher. Same noise level you will find at the Tektronix. The Rohde and Schwarz at the right hand is showing a noise floor equivalent to the signal shark. At a level of minus 80 dBm, all analyzers are able to show the signal easily. Now let's reduce the level of the generator by 10 dB. Minus 90 dBm, no problem. Minus 100 dBm, still visible. Minus 110 dBm, still visible. But on the Tektronix the signal-to-noise ratio is only 10 dB. Minus 120 dBm, and you can see on the Tektronix the signal is no longer visible. On the Anritsu SpectroMaster it's very tight. On the Signal Shark and on the PR100 it's still visible with more than 10 dB signal-to-noise ratio. So the scoring: 1 point for the Tektronix only, 2 points for the Anritsu, and as Signal Shark and PR100 are roundabout equivalent, there is no second place with 5 points, but 2 winners with 10 points each. Summary of Step 1 sensitivity is: the difference between best and worst is 10 to 12 dB. This means compared to H500, H600 or SpectroMaster, Signal Shark and PR100 can measure 4 times the distance or 16 times the area. This is a quite huge area. Preamplifiers have been switched off as they have a negative impact to IP2 and IP3 values. Let's continue with the second test, harmonics. Situation: you are searching for an interferer in the 1800 MHz uplink band, but the second base station on the rooftop, which is operating in the 900 MHz band, is overdriving the input of your receiver. Therefore, the input stage of your receiver or analyzer is generating harmonics at double frequency of 900 MHz, means at 1800 MHz. The problem is to distinguish between the external interferer and the test instrument internal artifacts. Best would be if your test equipment does not produce any artifacts. Then you can be sure all you see on the screen comes from outside the analyzer. For testing our analyzers, we systematically increase the 900 MHz signal and wait until the second harmonic at 1800 MHz is showing up. On the screen of our analyzers, we monitor the frequency range from 800 or 850 MHz to 2 GHz to see the fundamental and the harmonic simultaneously. Equivalent to test 1, we apply the same signal to each analyzer. However, this time we increase the amplitude by 10 dB steps until second harmonics become visible. Best would be if no artifacts are generated by the analyzers themselves. As the generator also produces harmonics, we put a 900 MHz bandpass filter in between analyzer and generator so that any harmonics of the generator are suppressed. Let us start at a level of minus 40 dBm. On the left-hand side of the screen, you can see the fundamental at 900 MHz. On the right-hand side, where we did the white circle, we are expecting the second harmonic at 1800 MHz. At minus 40 dBm, no harmonics show up, but what we can see again is a big difference in the noise level. At minus 30 dBm, same picture, silence. The PR100 seems to show some other artifacts, but we will not interpret them. Finally, at minus 20 dBm, 3 or 4 instruments show up with harmonics at 1800 MHz. According to the amplitude, we are scoring again. Means 1 point for the Tektronix, 2 points for the Anritsu. The surprise is the PR100 from Rohde & Schwarz. Their preselector, designed as a tunable filter, does not protect the input mixer 100% as we can see. But clear winner of this contest is the Narda Signal Shark. The screen is showing absolutely no harmonics. So the sub-octave preselector of the Signal Shark does a perfect job, rewarded with 10 points. The scoring again in a table. So after 2 rounds, Signal Shark takes the lead. Test number 3, intermodulation. This time we are facing 2 base stations in the same frequency ballpark at around 700 MHz. If both downlinks overload the input stage of the analyzer will generate intermodulation products which might fall into the frequency range of the downlink of the base station. Therefore, instead of hunting for interferer, you are hunting intermodulation of the analyzer, what needs to be prevented. During our test, we apply 2 signals to the input of the analyzer and increase the level until the intermodulation becomes visible. Like the test of harmonics, this test will show the large signal immunity of the input stage of our test candidate. But keep in mind that the sensitivity of the candidate is not equivalent. With 2 times minus 40 dBm at the input stage, 3 of 4 candidates, the Signal Shark, the Spectromaster and the RF Hawk, show no intermodulation. Only the Rohde & Schwarz PR100 shows already that its large signal immunity seems not to be as good as the other instruments. At 2 times minus 30 dBm, the same picture. Only Rohde & Schwarz shows not only intermodulation but also other artifacts. 2 times minus 20 dBm is separating the wheat from the chaff. Tektronix and the Rohde & Schwarz are showing saturation effects. A measurement is no longer possible. Only Anritsu and Narda are still able to handle this level. As the intermodulation products are lower at the Anritsu, this instrument gets 10 points for the IP3 value, 5 points for the Narda, 2 for the Tektronix and 1 point only for the Rohde & Schwarz. The scoring again in a table. However, remember you can reach any IP3 value, you just have to make the instrument insensitive enough. Therefore, in terms of dynamic, it is not clear who is the winner. Anritsu is showing better IP3 value, but the Narda has, with the same setting, the better noise values. So how to compare the dynamic in that case? To be able to compare the dynamic range of Anritsu Spectromaster and Narda Signal Shark, we would need to use the input attenuator of Narda Signal Shark. This will desensitize the Signal Shark. Other analyzers use the expression low distortion mode in contrast to low noise mode. Finally, it means you switch on an input attenuator. By changing the input attenuator, we can try to find the balance between noise and distortion. With no input attenuation, noise level of the Narda compared to the Anritsu is much better. With 5 dB input attenuation, the noise level is still better and the intermodulation products are round about at the same level. Seems like we found the champion of dynamic. Another 5 dB and total 10 dB input attenuation provides final certainty. The winner in terms of dynamic is a Signal Shark. Noise floor at the same level, but intermodulation disappeared nearly completely. The table shows a clear winner, Narda Signal Shark. A dynamic range comparison between Rohde & Schwarz and Tektronix was not possible. Noise is better on the Rohde & Schwarz, intermodulation better on the Tektronix. So, 2 points for each. And No. We would like to share also some effects we found during our test. The first takeout: compare the measurement speed. Especially the Anritsu SpectrumMaster, as a representative of the old style of sweeping spectrum analyzer, is due to a large span and small resolution bandwidth very slow. All analyzers are using FFT analysis to speed up the scan of the frequency range. But champion again is another Signal Shark. If you set the speed of the slowest analyzer to 1, Signal Shark is doing the job of more than 100 times faster. Therefore, the Signal Shark can do the job more efficient and you have a higher probability to find intermittent signals. Therefore, Signal Shark, 10 points for speed. Takeout 2, the input attenuator. Remember, to find out the perfect dynamic range, we played around with the input attenuator. So with the Signal Shark, you can tune the input attenuator in 0.5 dB steps. Anritsu and Tektronix in 5 dB steps, and the Rohde & Schwarz has only a single step of 25 dB. So yes, this is killing all intermodulation, but also everything else. A fine alignment is not possible. Sorry, Rohde & Schwarz, minus 10 points. Takeout 3 and the pole position. The detector in the SpectrumMaster, real signal killer. We've been using peak detection most of the time. Why not RMS or average? This is normally the preferred setting, and RMS and average setting is increasing the signal-to-noise ratio of an analyzer up to 10 dB. However, on Anritsu and Tektronix, it is mandatory to use peak detection if you scan or sweep a large span. Otherwise, the level of the displayed signals decrease in this example by 20 dB. If you switch the Signal Shark to RMS, it has absolutely no impact to the level of the carriers, and the displayed noise level with RMS detection decreases as expected. Moreover, it's getting even worse when you apply the sample detection on Anritsu. Now we are missing 80 dB signal level. Signal Shark still is keeping tall amplitudes as expected, even with sample detection. So, minus 10 points for the Tektronix. And Anritsu, we better don't do an assessment. An instrument which is named SpectrumMaster and which doesn't show the spectrum anymore has forfeited its name. Yes, there is a hint in the manual of the Anritsu. Nevertheless, not on the screen, and sorry, narrow peaks are important. That it is possible to show correct levels even with sample detection, Signal Shark has proven. So, the final evaluation: Anritsu SpectrumMaster, very good RF performance, but too insensitive. And very strange behavior in terms of choice of detectors. And slow, very slow. Tektronix H500 RF Hawk, medium RF performance and many times faster than Anritsu and Rohde & Schwarz. Rohde & Schwarz PR100 DDF007, very sensitive but large signal immunity missing completely. In such a case, an input attenuator can help, but here Rohde & Schwarz provides only a single-step 25 dB attenuator, so better keep this instrument away from any transmitters. And what about another Signal Shark? It's the best in noise or tunnel, it's the best in harmonics or IP2, it's the best in dynamic, it's the best in speed, it's the best in input attenuator, it's the best in detectors. So what are you waiting for?